Hi, my name is Justin. I was the team leader for Team 1, the hydroponic team, for the past couple weeks. Uh, Going into the position of the leader this past couple weeks, I knew that we were going to have to focus on designing the system itself in SolidWorks, and I wanted to set us up for the final stretch and get us going with the report. We did a lot of research and have a lot of information, but I think now we're really going to start putting that information into a coherent report and get that started. It's also helpful too because one of the major challenges of our team is the location of all of our team members. We only have 3 out of the 5 team members here in State College. 2 of them are um, a long ways away from State College and are unable to meet in person. So, as the team leader for the past couple weeks, I wanted to make sure that everyone had a task and everyone was able to contribute to the project. So, what I did is I delegated tasks that were appropriate for each team member. The 2 team members that were unable to meet in State College, I decided to have them begin working on the first draft of our report. I think, and it helped too because they also did a lot of research and contributed quite a bit on that front, so they were very comfortable moving into that position. As for the other 3 team members, including myself, we decided to go ahead and really focus on the design and get that cemented in. What I did originally is I went to Home Depot and checked out the different PVC components and what they had to offer to try and formulate kind of the materials we were going to need and what was actually going to be possible for our design. We had a general idea of what we wanted to do, but for the actual design, we needed to know what components we had at our disposal. And so we went and did that and got a sense of how much it would cost as well, so that we could do a full cost analysis. So Ben and I and also Morgan contributed into putting the design together in SolidWorks. We had a couple challenges with trying to figure out how to get the water to flow through the system, how were we going to pump the water, and how we were going to distribute the water. So I'm going to quickly run through the system and how it works. So we decided that we wanted to make the system electric free. That way we didn't have to worry about powering it or trying to add a solar panel system or something to the actual hydroponic system in order for it to be manageable. So we decided to go with a manual hand pump, and so what we do is we pump water out of a reservoir, and the water will go up the tube and flow into a fitting that will distribute the water evenly between 2 separate runs of PVC pipe. That PVC pipe will have holes cut out of it every 10 inches, and so we'll have 4 holes to insert our plants into. So we'll have a total of 8 plants in this system, and what we had to do is, because the pot is a circle top but it lies flat, we are cutting a 3-inch hole down, and then we're going to actually insert a section of 3-inch pipe that it will be able to sit in, and we won't have to worry about it moving around in the pipe as the water is flowing through it and as the plant is growing up. So that was one challenge that we solved. And another challenge was, once the water passes through this run of pipe, how is it going to get back to the reservoir? So the run of pipe is a 4-inch, and when we went and looked at the fittings, the 4-inch fittings were actually much more expensive than the like 2-inch fittings. And so what we decided to do was to use a reduction coupling and reduce it from the 4-inch pipe down to 2-inch. And when we did that, we were able to save some money through just the cost of the fittings themselves. So what we did is we took the 4-inch, dropped it down to 2 inches, and angled them down into a P-trap with a clear out. The water will actually drain down through into that P-trap piece down, and it will actually be reduced again to a 3/4 inch pipe. The 3/4 inch pipe will then run back down into the reservoir and drain and be ready to cycle through again. This was a pretty straightforward solution. We tried to make it as simple as we could, and I think this is one of the most effective ways that we were able to do that. One of the other challenges that we had to come up with was a structure under the system in order to support the system throughout its process. In order to do that, we're going to use 2x4s and just create a simple T-frame, and that should be no issue at all with the way our system is designed. But moving on to the greenhouse that it will be enclosed in, what we decided to do was use 2x4s for the base and then take a 1/2 inch electrical PVC conduit, and it'll have a 20-foot run, and what we're going to do is actually bend it so that it goes around from one side to the other and clamp that in to both sides, and that'll be that circular frame of the greenhouse structure. Once we get the frame up, we're going to be using 4mm plastic sheathing, and we're just going to drape that over the top and along the sides to completely enclose it. We're going to staple it into the 2x4s, and we're also going to be using tape in the different areas to prevent airflow and prevent loss of heat. We're also, instead of building an entire door, we're actually going to use an adhesive zipper so that we can easily move in and out of the structure. Very low moving parts and a very simple solution. So once we knew what parts we needed and the materials we needed, we were able to figure out the exact cost of the system. We used all the price points from Home Depot, the website, and we also ordered a few things off of Amazon as well. The total for this actually came out to be about $230, give or take, and which is about what we were planning on. And that includes the PVC system and the greenhouse structure. So now all we're going to be doing is waiting for the materials to come in. I had emailed Mandy with the materials list and the orders that we were looking for, and I also talked to her about in case we have any issues with certain materials that we're going to need to exchange, or maybe we are missing something, we can just go ahead and just email her again and work through that. As for the actual building the system, that's where we're running into a challenge. We need to figure out the space that we're going to build it in, and we're also going to need to find tools. Morgan had suggested that there's workshops available with tools available so that we can actually cut the PVC and put the system together. Once we do that, we'll be completely ready to build the system, and I think all of us are pretty excited to finally see this system in real life and see how it performs. So now looking forward to what needs to be accomplished, and as we progress as a team, we're going to be attempting to build the system itself, test the system, figure out if there's any flaws in the system that we need to address, and we're also going to need to try and evaluate the efficiency of the greenhouse. Should be pretty warm in there with the summer heat that we've had lately, but we just want to make sure that in the tundra climate that we're going to be utilizing this system, we want to make sure that it actually is effective at doing what it's supposed to do. We're also going to be looking ahead and trying to formulate the rest of this written report and get that finished up, hopefully ahead of schedule, so that we can edit it and revise it and make sure it's perfect for when we go to hand it in. So thank you for listening to the report, and looking forward to hearing what you have to say. So thank you for taking the time to listen to my presentation on our project, and look forward to any comments that you have for our team as we move forward. Thanks.